Hello everyone and welcome to 11.5 part 1, and we're going to be talking about arithmetic sequences today, and then the second video, 11.5 part 2, will be about finding sums of arithmetic, and our goals are to recognize an arithmetic sequence, to find a general rule of the nth term, and this we have already done through explicit and recursive, so that will come back here. And again, the second video will focus on finding the sum of arithmetic sequences. And so the question is, what is an arithmetic sequence? Well, it is a sequence in which the difference between consecutive terms are the same. And so a difference is really the subtraction of two values. So if you're looking at a bunch of numbers and the differences between them are consistent, that's what makes it arithmetic. And again, the word consecutive really means numbers next to each other. And symbolically, if you wanted to talk about what a common difference is, let's say that D then would be, let's call the first term A sub n and the second term A sub n plus 1. So if you wanted to find the difference, you would take A sub n plus 1 and subtract A sub n. And so this is really what a common difference is symbolized as. You could also say, if you kept going, that A sub n plus 2 minus A sub n plus 1, this difference would have to be the same as this difference in the terms in order to be arithmetic. So let me show you what I mean by that. So in these examples, we want to use the common difference to determine if the sequence is arithmetic or not. So what we could do is look at the terms, the output values here, and say that the difference between the second and first output value is 1, the difference between the third and second output value is 2, the difference between the fourth and third output value is 4. Because these numbers are not consistent, you could also write it as plus 1, and then between here is plus 2, here is plus 4. Because they're not consistent, that means that the sequence is not arithmetic. The second example, however, if you look at the difference between the second term and the first, that is negative 0.5. Then the difference between the third output value and the second output value, that is also negative 0.5. And so if you looked at it going from the second term to the first, from the third term to the second, each time the common difference is negative 0.5. So you would say, for example, 2, the common difference equals negative 0.5, and you would say that it is arithmetic. So what I'd like you to do is please try 3, 4, and 5 and determine if it is arithmetic or not. So please pause now. So if I check back in with you, number 3, when I kept subtracting from the second to the first, I kept getting a consistent pattern of adding 4, which meant that my common difference was 4, and I said it was arithmetic. Number 4, what I did was actually used logarithm rules. If I subtracted the second term from the first term, that's really ln of 2 divided by 1, which is not equal to the difference of ln of 3 minus ln of 2. If we use the rules from the logarithm section, that would be ln of 3 over 2, and these are not the same, so I said that it was not arithmetic. Number 5, I said that the common difference between each term was plus 0.4, so I said that my common difference was 0.4, and yes, it was arithmetic. So the next example, explain why the following sequence is arithmetic. It very much goes with what we were just doing. If we looked between the second term and the third term, if we took 8 minus 3, if we took 13 minus 8, and 18 minus 13, we would consistently get a common difference of 5. So we know that it is definitely arithmetic. And the question is, why does this really matter, and what does this connect to? Well, remember that these are output values. So if I represent first term, second term, third term, fourth term, and underneath, as we did in earlier videos, put output value, output, and output. Remember, all of these are really points. 1, 3, 2, 8, 3, 13, and so on. So if I took a little time to graph those points, an arithmetic sequence is always going to come out to be a particular type of graph. So if I'm careful graphing these points, 1, 3, 2, 1, 2, 3, 4, 5, 6, 7, 8, and 3, 13, it looks like to me that I'm going to be getting a straight line, which makes me think that an arithmetic sequence is always going to be linear, and that's something I would highly suggest writing down. So if I connected those points, again, I know my graph isn't perfect, but if I connected those points, we could look at what the slope is of this line. And if I looked from point to point, point to point, this looks like it's up 1, 2, 3, 4, 5 over 1. This also looks like it's up 1, 2, 3, 4, 5 over 1. And so if I kept going down 1, 2, 3, 4, 5 over 1, it looks like I would land on the y-axis here. So what's interesting is that the slope of this line is 5, and the common difference is also 5. So when you're finding a common difference, you can think of it as really slope because all arithmetic sequences are really linear. So before we change slides, one other thing to point out is if we look at this sequence and we want to find, based on earlier videos, the recursive sequence, that the next term, if we looked at the original, every time we were going up 5. So what we did earlier is we said that the next term would be the previous term plus 5. So I'd like you to notice that the slope is 5, the common difference is 5, and also this value in a recursive sequence represents the common difference. So if you're looking at recursive originally, this number would give you the slope or the d automatically. Which leads me to the next slide. Now, if I'm dealing with recursive sequences of arithmetic, the next term is always the previous term plus the common difference. So this number, again, helps you determine the slope. So that is really good to keep in mind for examples to come. And also what I'm going to do here is derive where the explicit nth term formula comes from. So remember, arithmetic is really linear. So I'm going to think about slope here. If you have certain points, so let's say that you have the first n term, the output value would be a sub 1. And if we go on forever, you could plug in the nth term, and then the output would be a sub n. So if I thought linear and found the slope would be a sub n minus a sub 1 over n minus 1. But in this section, we know that slope is really the common difference. So we could say that the common difference equals a sub n minus a sub 1 over n minus 1. And if I thought of this a little bit like point slope form, y minus y1 equals mx minus x1, if we wanted to get this equation into this form, we could cross multiply and get a sub n minus a sub 1 equals d times n minus 1. And if my goal is to find the nth term, I would solve for a sub n by adding the first term over. So it would be a sub n equals a sub 1 plus d times n minus 1. And so this here would be the equation to find the nth term of any arithmetic sequence. And just to go through it again, a sub 1 would be I would say it would really be the output value for the first term. N would represent the term number, and a sub n would be the output value of the term number you're on. So both of these equations are going to come in handy. So if you need to pause the video now to copy this down, that's wonderful, but I'm going to keep going to show you where these things come from, how we can use them. Find the formula for the nth term of the arithmetic sequence. As soon as I see it's arithmetic, I see nothing about recursive, I'm going to write down the formula we just derived. A sub n equals the first term plus the common difference times the term we're on minus 1. This particular example gives me that the first term is 15, so I'd plug in 15 for a sub 1, and it gives me that the common difference is 4. And so this is a good thing, because if I want to find the nth term, all I have to do is distribute the 4, and then combine like terms, and I would get that my equation is 4n plus 11. And this formatting makes complete sense to me because this looks like y equals mx plus b in a way, which is linear, so the idea makes sense. So it says that here your common difference is 4, as we knew from the beginning. The second example, though, is a little bit more of a pain because we do have the first term, which is nice, but it looks like we don't have the d and we don't have the slope. But we can find the slope or find the common difference because we actually have 2 points. So the first term, the output value is -4. The fifth term, the output value is 16. So if I wanted to find my common difference, I could really find slope. 16 minus -4 over 5 minus 1, which would really be 20 over 4, or the common difference is 5. Now that I know that the common difference is 5, I can use it to help me with this equation again. So I'm going to write a sub n equals a sub 1 plus the common difference, n minus 1. I know that the first term, I know that the first term is -4. A sub n equals -4 plus, here's my common difference, times n minus 1. Again, we can distribute -4 plus 5n minus 5. A sub n equals 5n minus 9. So that would be the equation of my nth term. And both of these, now that you have these two equations, you could find any value you'd like. So if I want to find the 7th term, you would plug 7 in for n. If I want to find the 11th term, I'd plug 11 in for n. So that's the reason why we want to find these equations. The next example is similar to number 2, but has a little bit more to it. Given that the third term, the output's 12, and the 10th term, the output's 61, they're part of an arithmetic sequence, we want to find the value of the 20th term. So eventually, we want to plug 20 in for n. But first, we need to find the equation. And this time, unlike the last two examples, I don't have the initial term. So I'm going to have to find that. But even before then, what matters most is that common difference. So just like the last problem, I'm going to find the common difference, which is really like slope. So on the third term, the output is 12. On the 10th term, the output is 61. So if I found the common difference, we'd have 61 minus 12 over 10 minus 3, which is 49 over 7. So my common difference is 7. So if I wrote down the equation of the general arithmetic sequence, what I can do so far, we don't know what a sub 1 is. We do know that d is 7, but that is it. In order to have the equation, I need to know what a sub 1 is. So let's think backwards. We have 2 points here, and both of these points could be considered n, a sub n. So let's pick one. If we pick this point, the output value is 12. So the 12 would go here. We don't know what the first term is, but we do know that the term number we're on is 3. And so let's solve backwards. 12 equals a sub 1 plus 7 times 2. 12 equals a sub 1 plus 14. A sub 1 is going to equal -2. So that means that my general equation would look like this. A sub n equals the first term plus the common difference times n minus 1. And if that's simplified, that would be -2 plus 7n minus 7. So that would be 7n minus 9. So this is my general equation. And now that I have my general equation, that means I can find a sub 20, which would be 7 times 20 minus 9. So a sub 20 would be 140 minus 9. So that output value would be 131. So on this problem, we had to find the d, we had to find the first term, and once we had those two, we were able to find our general equation. And then once we had that, we were able to find the actual 20th term. So guys, there's 2 examples I haven't finished yet. So what's going to happen is if you can go to the next video, I'm going to finish those 2 examples as well as start the arithmetic sum section. So thank you for watching this part, and please go to part 2.